All right, Sage, should we start in on pull requests?
Yeah. Let me just start it. Hold on. Sorry, 1 second. Right. I don't know if anybody else is having this problem, but the Etherpad doesn't load for me in Chrome. I use Firefox.
I had it open in Chrome yesterday, and it was fine. It was one of the things I was loading up on my box to make the memory usage go into swap, or make memory go into swap. Because the Etherpad is so piggy.
Yeah. Font. We gotta fix the font. It's super annoying because the font size is all weird, and then the like the numbering on the left hand side, like it's all uneven. The font is all jacked up. Anyway, important things. Okay, so updated RocksDB to current upstream, fixed a few bugs. We probably don't want to touch it again until after Mimic is released because I want to get plenty of testing in on that version of the code. Let's see, there's something about map splicing, merge the master. That's a C++ 17 thing, I guess. The Beast frontend is no longer experimental. Woo, that's a milestone. So we want to do a lot of testing on that. We need to make sure, I guess they're doing a review to make sure that there's no missing functionality. But as far as performance goes, it should be much better than Civet Web. Use far fewer threads, all that stuff, less resource intensive. So that's exciting.
Have there been any performance tests before marking it non-experimental?
I believe they've done a bunch of performance tests, but I don't know what they are. I don't know. Yeah, check with checklist. Or maybe who's on here?
Casey's on.
Casey's here.
Hey, folks.
How fast is Beast?
We really don't do a lot of performance testing other than just running, smoke test with Crossbench. And at this point, it's pretty much the same performance-wise. I mean, it's giving us a groundwork to get more asynchrony in there and reduce the number of threads, and that's the real goal. But at this point, it's pretty much where Civet Web is right now.
Okay.
Yeah, I mean, there's been some downstream testing. That's what they found too so far. Is that it doesn't really change the picture now. It ought to be able to handle many more simultaneous connections, and so there could be some impact from that.
So there's a different. Well, Civet Web has a thread per incoming connection. Beast,
right? And we
so it eliminates that whole thread pool.
Beast still uses the same bottom half, so that's our thread pool. For the moment, that's what Casey's getting at for how we might unify everything and reduce to threads per core or something like that. But for now, but it's probably C10K, and there are environments where it's really scaled up, and we've got thousands and thousands, lots of RWs just to get connection density, for example. That would be a big help.
Okay. So right now, is it still one thread per connection, or is it using a smaller number?
Technically, it's one thread per request because we call process requests synchronously.
Okay.
There's not a huge distinction between the two, though.
Okay. So the reason I ask is because with current RGW with Civet Web, I do see a lot of TC malloc nastiness trying to deal with its thread cache and doing crazy things. So that was one of the reasons I was curious. But
yes, we run way too many threads.
Yes, indeed.
Interestingly, though, Abhishek has been looking at pulling up to upstream Civet Web, and they've changed their threading model a bit. And so I think that it should accept incoming connections without tying up threads. So I think upstream Civet Web should give us the same stuff that Beast is right now.
Okay.
Okay. Is that gonna merge for Mimic, or is that what we're looking?
I hope so. I think it's pretty much ready.
Okay.
What's the plan with changing the request threading model? Is that something we're looking at, or?
Yes, I've got a design for making process request itself asynchronous, so that when used with Beast, it can suspend the coroutine and resume when it completes. And once we have that, then we can look at reducing the number of front-end threads significantly.
So just to clarify, does swapping CivicWeb for Beast, does that actually eliminate the CivicWeb thread pool, but keep the bottom half? Obviously doesn't change, but does it actually reduce the top half threads?
Well, the Beast front end is creating the same number of threads that the CivicWeb front end would.
Okay, in order to match the bottom half. Okay,
yeah,
so this is a refactoring progression, but it's not really going to change much of the behavior then.
At this point, right?
Yeah. Okay.
Well, relative to, I don't know. This newer, it's new this to me this week, but I assume that I'm not surprised that they would eventually fix things, but they've been pretty terrible about it. I tend to look past CivicWeb as much as possible. But yeah, I think it's supposed to mimic at this stage. But my goal is for us to be on an accountably small number of threads. Certainly by let's say Nautilus. And people like Casey have agreed to backport things. So my goal would be to see us be able to have some mimic that has.
Yeah. Okay.
Yeah, but going forward, the end goal is to use Boost ASIO to have kind of a small number of threads and run the front end and all background work on those same threads to eliminate most of the other threading that we're doing internally.
That sounds great. Cool. Okay. What else? There's this auth rework that Kifu's working on. I haven't been following that. I guess just clean up. QAT, lots of review and revision going on there. That's the quick assist Intel acceleration for things like compression. Still looking forward to getting that in because that'll accelerate the Blue Store compression and the RGW compression on the wire, that sort of stuff. Let's see. There is optimization from Radic, I think, that avoids some HObject tmem copies that's in testing. Similarly, reducing some ref counting. These are all just small optimizations that improve things a bit. Those are likely to go in shortly. Let's see, there's this RGW ability to do unordered bucket content listing that is in progress. You guys want to talk about that a little bit?
That really should emerge, I think, at this stage. If that hasn't already merged to master, Casey.
Yeah, it's ready, but Eric was fighting with make check failures on ARM, so I think we might want to just merge it anyway.
Yeah, I think let me do that.
Maybe run it, test it, because the last make check on x86 also failed. So trigger a new test.
Okay.
Okay. Let's see. Radic has a whole bunch of changes to the op tracker that Greg reviewed yesterday. Looking good. I don't know how is that gonna merge soon, do you think, Greg? Has it gone through testing yet? What's the status there?
I was just looking at the code, but Radic, have you done anything with this? Or rather, what have you done with this? Because you have numbers, so clearly it's run.
Hi, Greg. I've seen your comments. Thanks. I'm responding to them right now. We'll make some extra docs and maybe unit test for the tiny vector soon.
Okay. Maybe we can try running it through QA. Once it's ready, right? If you ping me, I can queue it up to run it through QA and see how it does. We'll see if it seems ready to merge yet or not.
Sure.
Let's see. There's the right lock thing from how Peter reviewed it. I'm not sure. What are we waiting for on this one? Is this ready to go? Avoid put message within. Oh, he's got a question. Let me ping how he has a question. But that's also a simple thing. It'd be assuming whether it's not an issue. The recovery optimization stuff with overwrites is still in progress, so that's definitely not going to make it. Let's see, the huge pages for BlueFS. Where are we at with this one? I think it's.
I implemented. I've put a fallback mechanism for handling the situation where we cannot get underlying page. What we can do also is to provide some kind of additional backup adaptation mechanism to not go unnecessarily to mmap if you are seeing continuous failures of huge page allocation.
Okay.
Anyway, I've put off the DNM flag. This adaptation would be seen as just an optimization of on top of the current change.
Okay. I wonder if we want to have the caller explicitly hint that it wants a huge page instead of like trying it if you have a magic allocation size or something.
I tried transparent huge pages and yep, got some of them. Unfortunately, not all of the allocations have been served with transparent huge pages. It's only a best effort mechanism.
I'm thinking that we actually would create a new buffer method. Like right now, it's like create aligned or whatever. It'd be like create huge TLB or whatever, so that.
Oh, okay, to have the mechanism explicit.
So only BlueFS would be the one trying this path, and we wouldn't have to do some like weird dynamic back off on mmap if it's failing.
Okay, I will do.
I think
makes sense.
More transparent and simpler.
Anyway, do we have any other? Okay, we could do. Not sure.
Buffers like
I just wonder about another potential users of really big buffers in Ceph. RBD reads of for make segments.
I mean, I guess if you're doing just a read of greater than of 2 or 4 megs, like we get those in Rados, we could use them there. That might make sense. Yeah. So in BlueStar, if we just are reading a large buffer, we could do it. That might work.
Okay, so it seems it still would need a small additional change to handle not only 2 megs, but it multiplies as well.
Yeah, but for now I would just have an explicit like.
Okay, got it.
Okay, and we can add the other use cases later because this is the main one that matters, I think.
Yep.
Is this PR dependent on transparent huge pages?
No, it's not.
Okay, thank you.
It's not. It's not used.
These regular ones. Yeah. Okay.
It does it uses the explicit huge pages, not transparent ones.
Thank you. I just wanted to understand that. Thanks.
All right. So there's periodic discard, still under revision. That like the automatic inline discard stuff is in the tree, but it seems to slow things down, so it's off by default. Probably will remain that way. So if discard remains lame in general on SSDs. Let's see. We've got these 2 bits, 2 from Adam about improving the hashes. I think this reduce collisions on meta requests and collision. Oh, okay. This looks like a small change. I haven't seen this one. Yeah, I should probably test it. Oh, he needs, yeah, he doesn't have tests yet. Let me ping him. What else? Other hash collisions. This is the one. Oh no, map improvements. I need to review that one. And then everything else here is old. This EC stuff. Yeah. All right. Okay.
Hey, Sage.
Yep.
Can I ask you a question about mmap versus pread? I noticed in a lot of the stuff that we are looking through that a lot of times when we're doing reads of like different entries in one of these SST files through BlueStore and doing all these different pread calls, my understanding is that pread is faster than mmap if you're like reading to a known offset or reading from a known offset, like doing little reads of something. But it almost seems to me like when you look through all of the reads, it's kind of like the whole contents of the file just at different times in different places. And I almost wonder a little bit if you're better off just mapping the whole thing in rather than doing like preads of these different offsets. Maybe it really doesn't make sense in the long run, but I'm just kind of trying to, as we're going through all this.
So the problem with
Go ahead.
so for these random reads, the problem is that we're generally doing direct IO, so we're bypassing the page cache, which is mostly fine. The problem is that when you do a small unaligned random read, then what we're doing is we have to align it. So we expand it to include go to a block boundary, and then we read that in, and then we copy the piece that we want. So I think doing mmap would help in a case where we do multiple of those small reads within the same block. Then it would help, but otherwise that doesn't. I don't think it matters.
Okay.
The reason I didn't like feel very good about implementing the like small random read that way, but I just looked at the RocksDB POSIX backend and it does the same thing. So when you enable ODirect for RocksDB in general, and it's just sitting on top of regular files, it's doing the same thing. Where when it has a small read, it just reads the whole surrounding block ODirect and copies the bit out. So we're not doing anything really different than regular RocksDB does. I don't know how often people really enable ODirect though. So, and they're not like the experts on on IO either. So, yeah, I think for like the ones where we're hitting the bugs right now, they're actually large reads, but they're unaligned, and so we end up reading a big like 600K into one buffer and then copying it into another buffer. I think that's actually not really any different than what we would get with mmap because it would also land in the page cache, which would be the first buffer, and then we'd copy it out of the page cache into the user buffer. So it's effectively the same thing, except that pread is probably going to do a little bit better than mmap in this case because we know that the what the read pattern is. Like you're going to read all 600K instead of like faulting a sequence of 4K pages in as you go. So I think it's better in that sense.
Sure.
Otherwise, you'd be relying on like the read ahead detection or whatever to notice that it's sequential and then read ahead windows, all that crap. Whereas here, you're just like read all 600K, done.
Sure.
Okay. Should we talk about cache balancing?
Yeah, there's not much to
Nothing
report,
really to report.
unfortunately. Just that
Yeah.
we're still struggling through all this bug stuff, and I thought I'd give people an update to let them know.
Yeah.
But my plan right now is to continue nasty, ugly testing on my box, and since Incerta doesn't seem to be suffering from it, just move over the cache balancing testing and development there. So
Okay.
I'll leave this box alone to do this stuff, and then go use my laptop to develop the rest of this on Incerta.
Sounds good. Okay. Yeah, it'd be really nice to have at least the like basic version of the cache balancing stuff in Mimic and get that
Yeah.
back ported to the next Luminous point release. That'd help. For those who haven't been following along, there's a blue store bug where RocksDB reports a CRC error. We finally have a machine that can reproduce it. It's Arc's desktop, and it appears to be pread, the kernel pread syscall returning random zero regions. Not random, but yeah, parts of the pread result are zeroed out, even though the return code indicates that it read the whole buffer. So it looks like a kernel bug. It appears to circumstantially it appears to be related or correlating with swap, but might be the swap code, not like swapping pages back in or something. That's the current thinking, but we're not sure. So if anybody has seen that or knows anybody who's seen it, given what we know now, we should like regather information about their environments and see if that matches what they saw. What kernel versions, whether swap was enabled, whether the machines are swapping. That's it. All right, buffer list, small vector. Radek has been working on this. You wanna share the current status?
Sure. I'm working. The idea is to introduce some optimizations to our buffer list. At the moment, we are aggregating buffer pointers using std list, which means a lot of memory fragmentations, a lot of memory indirection. I switched to a small vector for that. And what is funny is that in synthetic benchmarks, I'm getting significant progress both on my desktop and on our Incerta node. However, when it comes to macro testing, like firing a lot of requests against the RBD image on my local machine, I'm getting around 8 to 10% of improvement during 4K rand reads in the unbuffered scenario. Sorry, in the 100 cache hit scenario. However, on Incerta, I've got a slowdown, actually a regression. I'm investigating the issues, and let me share some links related to the case. First of all, our results on my machine. Here they are. Second thing is benchmark is the results of micro benchmarks on the Incerta node. During that, an interesting anomaly has been found. Basically, we got a regression in a synthetic benchmark that is perfectly unrelated to the changes we made. Unrelated by means that there is no difference even at the assembler level, except some alignment. So I made a TMM analysis, and it turned out that those those buffer-restricted code is usually a island of code that runs with very, very good IPC ratio, mostly using a decoded instruction cache that unfortunately has even stricter requirements related to alignment, to the number of jumps per cache line. I've posted them. I've quoted some fragments of the Intel reference manual saying about those requirements on the top, on the bottom of the last link. I faced a situation where putting a no-op system call made an improvement only because of rearranging the code. Yep, there are results put in the document together with changes, together with dumps from object dump. Finally, this turned into a workaround, basically allowing compiler to inline all calls to our maybe inline mem copy. After that, I've got interesting improvement in IPC, reaching around 5 instructions per cycle, which means that we exceeded the throughput of almost exceeded the throughput of processor running on so high only because of macro op fusion. Without macro op fusion, those CPUs are able to deliver up to 4 instructions per cycle, while we are getting now 5. Unfortunately, I've checked this also in OSD, not only in the synthetic test, and there is substantial difference. In the benchmark, the compiler was able to optimize the code further because all sizes has been known in compile time, which allowed to kill some branches, some unnecessary instructions from the maybe inline mem copy. That's not the case in OSD. I work at the moment. I'm taking a look on the RTE mem copy, which is implementation of mem copy coming from DPDK project. It's optimized mostly for networking, for dealing with quite small regions to copy, up to a couple of kilobytes. Maybe we could try to translate some ideas to our maybe inline mem copy. Working on that right now.
Okay.
But still, I have to find the reason why not seeing actually a regression on Inserta while testing the small vector.
I thought that after you added all the other changes, it was the same. Like the regression went away. Did I mishear that?
Sorry, could you repeat?
I thought you said earlier that that initially you saw a regression, but when you added all the other changes, then it was net 0. There's no change. Actually,
yes, on Inserta, it depends on the commit being tested. Okay. On Inserta, without the last top commit for inlining maybe inline mem copy, I'm getting around 2% regression and around 8% progress but on my local desktop mobile CPU.
Okay.
After testing the last commit that brings aggressive maybe inline mem copy inlining, I'm able on my laptop. I'm able to reach around 10%, while on Inserta, I'm at the moment there is no regression, there is no progress.
Okay. If you do just the inline part without the bufferless stuff, do you see an improvement on Inserta?
Not tested yet.
Okay.
Radek, I think it was a day or two ago. I was. Go ahead. You probably respond to Sage for Salasky then.
I tested on Inserta. I tested the scenario with basically only with aggressive inlining without small vector, but in synthetic benchmarks, not inside OSD.
I see. Okay.
Radek, I was wondering if you happen to have a chance to look at the behavior from like perf, if you saw anything interesting even on Inserta, even if the performance went down or didn't change or whatever, if it changed any of the behavior.
The IPC or whatever.
I cannot. I can observe there that after moving to small vector, we have completely eradicated calls to std list clear. That was responsible for around 3% of cycles during writes. Also, other appends looks better. However, it could be that the slowdown is caused is popping up in a code that was inlined somewhere else, somewhere that I'm not to a place that I'm not focused on. So also I'm started to forcing no inline on some common methods of buffer list. To see whether there is difference after the small vector or not. I was afraid about the push front that became slow in my commit. It's not related to the Sage changes that basically eradicate that kills the push front part of the buffer list interface. I implemented for small vector. I implemented them on the top of std inserter, which means that they are really slow. However, after forcing no inline on push front and friends, I still cannot see any usage of them. So I guess they are not on the hot path.
It strikes me that any time that we make a change and it affects performance because it may have an effect on how like GCC is inlining things or not. I mean, it's more the behavior that matters than it is the specific performance, because we're never going to be able to, who knows in future versions or old versions of GCC whether it decides to inline or doesn't decide to inline. We can't make decisions on what our code looks like based on kind of.
Moreover, we shouldn't.
What makes yeah.
To be honest, we shouldn't. All we need to do is to not prohibit the compiler to make the decision. It's optimized to do for us. However, there are a lot of cases, a lot of situations when we can disallow compiler to do its job. I mean, putting some very, very hot methods in a different translation unit, for instance, or having extra virtuals or without the final specifier, or there are many cases.
Yeah. I guess honest, in this case,
yes.
I was just gonna say in this case where it seems like the change that you've made should be good in general, and it's good on your laptop, and it's not necessarily great on Inserta for some strange reason, and it's good to investigate that. But I think if the change makes sense, it's still worth doing.
Remind me is this still with a inline of only one on the buffer list, or the small vector for buffer list with one entry pre-allocated?
Yes, we have on small vector at the moment we have only one slot inside the object inside the instance.
Okay. I wonder if we should retest it on
Okay,
COSD with like 3 or 4 or something, so that just 2 cache lines.
we can.
Because I have a feeling
We
on the
can, and
OSD when you
more.
have multiple. Yeah.
And moreover, there is a chance to have that without lowering our cache density. It seems that buffer list has inside instance of buffer list iterator, which is really costly. It has a lot of pointers. It's around 40 bytes or something like that. And it's necessary only because of some operations like advance or something like that, that we could try to build on top of the current index instead of the iterator. And current index is max size t, nothing more. This would allow us to increase the number of pre-allocated entries inside small vector for free,
Yeah.
or just to even drive the density higher, depending on what is better in testing.
Yep. Yeah, that sounds good. Yeah. Okay.
But still, there are at least 2 factors that can affect in the difference between my desktop and Inserta. First of all, is of course a different microarchitecture. Skylake got a lot of improvement when it comes to memory throughput. It could be that the copy operation that we have somewhere on the buffer list, we have excessive small vector copying that is almost for free on Skylake, but on Haswell it's not. It could be painful. Another factor. The second factor is that those CPUs are really differ in size. My desktop has 4 cores. One CPU at Inserta has 10 cores, different memory, different number of memory channels, and 2 CPUs.
Well,
for a total of 20 physical cores.
If I can break in here, I mean, so how can we construct? I guess I would ask how can we construct the framing, the mental frame, so that it's something that generalizes to Intel CPU architectures going back maybe 5 years, rather than rather than the ones that are highly dependent upon
the problem.
Detail. I mean, it's small vector. In other words, are you still investigating whether small vector versus some other sort of organization makes sense? I mean, it seems unsurprising, and we knew we knew back working on Firefly that we really wanted to change how some of this stuff worked. We had two theories: one that we wanted to get rid of atomics, and 2 that we wanted to get rid of list. I think this group and you personally are on both of these. So where are we at? So at the bigger level, at the more macro level.
We would need to have a server CPU of nowadays microarchitecture that we could test on. I believe that's the simplest way.
Well, I mean, could we just test on something slightly older? I guess assuming that one has Skylake isn't reasonable, but the larger implications of the data structures and atomics and so forth are general to lots of platforms. They shouldn't be showing up only at the edge of the leading edge of of the CPU release pipeline.
There is also third possibility that worries me a lot. It's because of much more stricter requirements for the code layout, for the code arrangement in places where you are in tight loops. This is because the decoded stream buffer, the decoded instruction cache, and it became quite popular across x86. Nowadays, AMD's chips have the same.
I guess one question that I've kind of asked before, and maybe we'll reiterate again here now, is the differences here aren't that big, right? I mean, we're talking a couple of percent. How much time is it worth really spending on it versus other things that are really obviously messy in the code that we kind of are scared of but probably should tackle?
That's the very good question. The main benefit from doing micro optimization is that you don't need to change the algorithm.
We lost you.
Yeah, we lost Radek, I think.
Yeah,
I guess the
if we're only
I was
getting a
just
couple percent on a real box, then yeah, if we're getting 10%, then this seems totally worthwhile. We've been talking about doing this for a long time. I think these are all like things that we should do.
Yeah, it sounds right to me.
Yeah.
it's but it's one of those things, right, where okay, we see results right now that show that, like, you know, on one architecture it's faster, on one architecture it's maybe slower. Is it, you know,
Yeah.
should we
I would
do
like
it?
to.
I mean, when you start
I
talking
would like
about
to see it on a
difference in
modern.
memcachy performance, are you now beginning to deal with things that are that is small, where small vector is rearing its head, where it's specifically the attempt to make small vector versus vector or something, or some other.
Sorry guys, I've got disconnected. What I've missed?
Not a lot. We were just waiting for you to return. Sage was explaining
Okay.
This is the theme that we wanted to, that we have to we have some. We have a lot of people have a long history of wanting to move in this direction, and Mark is asking whether we want to focus on other things because they're.
Yeah.
Well,
and I also respond.
So sorry, maybe let me clarify that quickly. Not even so much should we do it or shouldn't we do it, but, you know, since we're seeing kind of, you know, not real clear results, maybe we should just make a decision and do it or not do it, and not worry so much, because it's, I mean, it seems like we're not going to cover every single corner case here. We're just, you know, let's not talk about it endlessly. Let's just do it or not do it.
Yeah, I mean,
guys, I'm voting for C-Star.
Yeah. I mean, the C-Star stuff, I think we should aim on the OSD and C-Star to not use bufferless at all. Just use the native C-Star buffer management. I think we'll be better off if we do that.
Yeah.
And then we only need to do the glue stuff in like random cases where we're like sending stuff to the monitor or something. But that said, I think the this pull request that you have right now is a good idea. It's going to help everything else, including the client. And I like the idea of the iterator simplifying itself when you have a vector instead of an iterator into a linked list, and being able, we could probably even, the iterator class itself, having all those bazillion methods, we could probably collapse those down even, because a lot of them are just like redundant pointers that are like trying to avoid additional memory dereferences. But eliminating the iterator pointer from buffer list, if that lets us squeeze more inline entries into a single cache line, I think that would be great. So I'd like to see that. I guess that'd be my suggestion.
Okay, but still, it will be just a micro optimization, bulky,
yes,
but micro optimization. It won't. This won't be a breakdown. This won't bring 30% or something like that. No way.
Yep.
Even 3%, it would be a good result.
Yep.
It's going to make people feel good.
I believe that's just the trade-off that is really tightly coupled with doing micro optimizations. You don't need to change the project entirely. You don't need to exchange data structures. I mean, you are minimizing the risk of introducing, basically of starting from the ground up. for the increased cost of increased cost per line.
Yeah, it feels to me like we
crazy
just.
amount of time.
It feels to me like we need to pursue both, right? I mean, this is one of like 10 micro optimizations that we need to make that are collectively going to give us, more substantial change. But it's just a, death by 1,000 paper cuts in our IO path where we're doing like random string copy, random, small set manipulation, whatever. Like no single change is going to be that significant, but they add up.
We're not quite sure how all of them interact with each other either, right? It might be that we don't see the effect of one until we do all or something.
Yeah.
Yeah.
Yep.
Yes.
But I think my gut says that buffer list has become too heavyweight and inefficient. It's sort of optimized for this case of like having these complicated buffers and like stringing them together and whatever that we never actually do. Like in principle, in reality, the buffers that we're dealing with are like a small number of pointers that we assemble and like that's it, and that's all we need.
By the way, at the moment we are always paying cost of having CRC related stuff, even if a particular client of buffer list don't use it.
Yeah, I think we should probably rip out the CRC stuff. I don't think it belongs in buffer list.
It sounds like we would need a decorator or something like that.
Yeah, or just remove it. It's optimized for not recalculating the CRC when we journal data to file journal. Like that's the big thing where we CRC something twice, and that only matters for big writes on file store on slow processors, which like is not sort of our real target. So BlueStore doesn't have to double it. BlueStore is doing totally different CRCs on 4K pages or on blobs, and so it's going to have to recalculate it regardless. So I think that it's probably time to rip out the CRC thing. Probably. We should check. Just comment it out and run a test and like see if it actually matters. But I have a feeling that it's not helping us. It's not worth the memory. Anyway, okay. Anything else we should cover? We have a few more minutes.
What about C-Star?
It's going to solve all our problems. It's going to be awesome.
It's going to solve all of our problems. Yeah, I just got done doing a bunch of threading performance work in the straight C, in NFS Ganesha, and I ran into an issue where I hadn't touched this in a while, and it was just on operating on basically a lane-based data structure that's trying to get parallelism and with POSIX threads, and I noted, and I don't remember noticing this before, but I must have in the past, that I only got the runtime to the scheduler to run my threads enough at real-time priority to actually measure the measurements I wanted. This kind of shows where C-Star is giving us something huge that we're just not having to deal with. Mm-hmm. Setting aside all the NUMA and everything else it does.
Yep. It's going to be adventure. Kifu's alien stuff is working its way into C-Star. I think it's still under review, but looking promising. Once we have the sort of the captive reactor in the OSD, then I think the next step is to move over a bunch of the common infrastructure, enough of the common infrastructure that we can do meaningful work there. I think like GOut is the main thing that comes to mind. And then like the OSD map cache, things like that.
Yeah, related to that, so I was talking with Gifu about this a bit earlier, and I think the next phase is probably just to make GOut a printf, just for development purposes, and ignore all the logging infrastructure stuff, and to actually switch to like binary formats using trace points or something custom. Since the huge cost of string manipulation is just something that we can't bear from D out.
Yeah.
And I don't think it's worth re-implementing that in a new way that still won't work in the future for fast devices.
Yeah, I mean, it doesn't have to be fast, right? I think we're still going to need.
Well, no, the whole problem was that we can never turn it on in situations where we actually need it because it's too slow, right?
I see. Yeah.
We can't debug rare issues because we can't have logs running all the time, or even crashing at the time.
Yeah.
Yeah. And the fact that we're going to have future constructs means we ought to be able to have an awful lot of automated tracing, or of sort of programmatic tracing anyway. We can just like build that into the future constructs. We entered here, we exited here.
I have to say, just from personal experience, that over the last years, fallen into the habit of basically disabling all Ceph debugging and just using like external wall clock profiling to try to figure out what we're doing. That's just the habit that came about because of how impactful our debugging tends to be.
Well, yeah, that works for default profiling, not for actual debugging. But
it doesn't work very well for correctness issues is the thing, right? Yeah. If you have some kind of strange logic bug, you're not going to find it with profiling, most likely.
Yeah.
Yes, but the point was that it's heavy, right?
Yes.
And that's the same point you're making.
Exactly.
Yeah.
I think we're on the same page there.
Yeah.
Okay.
Sage, with the C-store planning, how will the object store interface look? I mean, or is it still way too early to even say?
I don't think it's actually the changes are that significant, except that buffer list changes to C-star buffer or whatever it is, and anything that blocks would return a feature.
We probably eventually switch away from encoding transactions explicitly and use the same on the wire as on disk, right?
That would be nice. Yeah, we should probably adjust the in-memory representation of a transaction so that it's can be sort of shuffled or whatever. Yeah. But it's
kind of a far-fetched thing, though.
Yeah, and it's not. That doesn't really work because the transaction in memory is a logical transaction, and the transaction that C-store is going to write down is going to be like, in this B tree page, change this key to this value or whatever. Like it's a lower level construct. So,
how does it interfere with the current RAIDOS protocol? I'm asking. I wonder whether the C-star in a C-star-based OSD plus C-star-based object store wouldn't result in a need to significantly rework the protocol itself.
So I guess the thing that comes up there is the addressing which shard a message is going to in the protocol itself, instead of having to read it off the wire and then figure out where it's going. I think that's something that we probably wanted to look at for Messenger 2 protocol that we're already starting to work on.
Yeah. Yeah.
Do you want the OSD itself to have some decision-making ability there, rather than having it encoded into the message?
Well, I mean, the OSD can always read it off the wire on whatever core the client thought it was meant for, and then shuffle it over to where the OSD thinks is best, if we need to. But ideally, it wouldn't. I think it would be kind of shared knowledge that the client has based on the current OSD map.
What makes me a bit afraid is that if we want to address those zillion IOPS providing SSDs, we will have very few instructions per very few cycles per operation.
Mhm.
This means that we might face a need to eradicate a complexity instead of introducing new one.
Yeah, that's definitely something we'll need to look at. Is making a fast path that reduces a lot of the extra instructions purely.
I did write down, start trying to summarize the draft design document for CStore the other day. It's not really done by any means, but I'll post it as a PR regardless. Let's put it in the chat. There's some detail there, not a lot. It's just a starting point.
Have we set our requirements related to the throughput, to the IOPS number we want to handle with the new things?
I think it's not necessarily a specific number. It's more to get the best use of the devices that we can that are available now.
Yep.
Asking because differentiating here could be helpful. And not different designs would be the different design would be needed to handle SSD providing 100 IOPS, and completely different to handle those ones that have 1 million of IOPS.
Yeah, absolutely.
Yep.
Your point earlier, Attic, about how many instructions we're doing now, I made an outline of the current IO path
At the moment,
and
at the moment in run feed we are. Sorry, please continue.
So you can see in that Etherpad, there's many steps there that are happening even before we get to the object store layer, which adds many steps of its own. And I think we'll eventually need to have a fast path that is able to do away with a bunch of these, or at least short circuit them.
Yep.
Yeah.
From
Josh,
from profiling,
Go ahead, Attic.
From profiling, I can see that currently for single 4K rand read, we need around 200,000 of cycles, which is a pretty large number.
Yeah.
And as far as I know, there was a decision made while developing the DPDK that there is just a constant, a priori node budget of cycles, GPU cycles per packet, and that cannot be never exceeded.
Right. Yeah, that makes a lot of sense when you're targeting like a specific IF number. I think in the general case, we probably can't do that if we're dealing with fully general radius operations that might do n different things within a transaction, and but we can certainly try to make a faster path for common operations done by our common protocols.
Focus on the common case.
Yep, that makes sense.
All right. This is a long document.
The funny thing in that document too, I was just looking at like issue repop and submit transaction that doesn't even get down into like log operation and how much. You look at like there's so much time spent in that. I mean, like submit transaction there looks really small in this list of things, but it's really nasty.
Yep, there's a whole bunch that's not even included there exactly. It's just the very top half.
Yep, it's.
All right, cool. I think we should out of time. Wrap it up for today. Thanks, everyone.
Thanks.
Thank you,
guys.
Bye.
Girl.